Good morning everyone. In the last class, we were discussing the solution of the a problem. We have considered the problem as this GSH is equal to K by S into S plus 3 S square plus 2 S plus 2, and we have calculated the corresponding values or the values which are actually required to draw the complete Root Locus plot. And you see, so there is a branch. I just repeat it. There is a branch between S is equal to 0 and S is equal to 3, and there is two complex poles, right? And according to by using the defined formulas, what we have obtained that there is a centroid, that is sigma is equal to minus 1.25, and there was a four angles phi is at 45 degree, 135 degree, 225 degree, and 315 degree. These already calculated in the last class. So in continuation with that, we see we have to draw one centroid at minus 1.25. say this is your centroid minus 1.25, and on that you just put your protractor here and draw the four angles. Like I can draw the angles like this, say 45 degree, this is one asymptote, you'll be getting this is 135 degree angle, and this is 180 degree plus 45 degree is 225 degree, and this is ultimately 180 degree plus this, that is 315 degree angle. So these are the four asymptotes. So four poles, four asymptotes. I repeat, four poles, four asymptotes, four branches, and four branches will terminate to infinity. So four branches, I will tell it like four branches go to infinity along the asymptotes, right? Along the four angle we have done. Now the thing is that we have calculated the breakaway point, because there is a breakaway between 0 and minus 3, and you see during the breakaway point determination there was a problem, and we have worked on the problem, and finally we get breakaway point is equal to minus 2.63 like this. So this is the approximate solution, and that value is near about to this point, say 2.63, that is here. So this is your S is equal to minus 2.63, which will be known as breakaway point, right? So till this point we have reached, and you see these two branches, once the breakaway point is determined, next use that the concept you can use. This is S is equal to minus 3, that means this pole is moving these directions when the value of K, that is the gain, is increased, and this S is equal to 0 pole, this is moving in this direction. They will meet on this positions on the real axis, and finally what will be happening that these two poles will be leaving the real axis at an angle of 90 degree, right? So we are getting two branches, one branch is along these directions and one branch is along these directions. There is no problem in it, right? And you see next what can be done. You see next, this branch when moves to this, so this is actually finding this root. This is one root, this is one root, this is one root, and this is one root. So four roots are given. So this pole definitely moves along this path and goes to infinity, and where the value of K is equal to infinity. Similarly, this path is just following this path, because this is one asymptote, and similarly at the same time what we know that Root Locus plot is symmetrical about the real axis. So this and these are symmetrical. So two branches originated from two poles, that function is covered. Now what else about these poles? These poles are on the complex plane. So once the poles are on the complex plane, what is the next step? You have to find out the angle of departure for that. So next step is to find out the angle of departure. Any complex pole, we have to find out the phi d, that is angle of departure, right? So angle of departure is equal to 180 degree minus of phi p minus phi z. Phi p is the angle contribution due to poles. So we will concentrate on this pole, and when we will concentrate on this pole, what we have to do, we have to join all the other poles and zeros with the considerations pole, that is the pole under considerations. So this is one joining, this is another joining, and this is another joining, right? So we will have three angles. This is one angle, this is 135 degree, that means this phi d I will write at 180 degree minus total angle contribution due to the poles, total angle contribution due to the poles. This is 135 degree positive, because we are measuring this angle anti-clockwise direction, and this pole to this pole, if you make a horizontal line here, you will get 90 degree. This is again plus 90 degree, as this is measured in anti-clockwise direction. So this pole is connected with this pole, and we are getting this angle, right? So this angle is nearly, we can tell it is near about 27 degree. So that is 27 degree. We can measure it by protractor. So ultimately this gives near to minus 72 degree, because there is no contribution due to this 0 point. So this is 0. So contribution due to all the zeros, because there are no zeros here. So we are getting the angle of departure minus 72 degree. So minus 72 degree means we have to measure it anti-clockwise directions. In anti-clockwise direction, if you measure, then we will get the, so we have to measure this angle minus 72 degree. Once minus 72 degree we will measure, then we will get the angle of departure by which angle this pole will leave this, that is branch will leave this pole. Okay, so angle of departure calculation is over. And second thing is that this is one asymptote which is going in these directions, and this is one asymptote which is going in this direction. So there is a possibility to have the intersection with the root locus branch, which will originate from this pole. Maybe this pole will originate like this and goes to in these directions like this. Okay, so in that case we have to find out the point of intersections with the imaginary axis by using the Root array. Okay, we will do it. So this is your characteristic equations. That means s into s plus 3 into s square plus 2s plus 2 plus k equal to 0. This will give you an equations which is I can see it, s to the power 4 plus 5 s to the power cube plus this is 8 s square plus 6s plus k equal to 0. And by using the Root array, in the same procedure we will have the value of k. We just form the Root array at the value of k, for which the one row will all the elements 0 0 like this. The value of k will be, in that case will be simple, you can see it 8.16. So, and corresponding to that, if you find out the auxiliary equations, because this case auxiliary equation will be formed, and once the auxiliary equation is formed, the auxiliary equations will be equal to your 35 by 44 by 5 s square plus 8.16 equal to 0. From there you can get the value of s, and which is actually plus minus you see you can calculate it 34 by 5 s square plus 8.16 equal to 0, which will give you the solution for s, means the point of intersection with the root locus branch, where this will actually guard the imaginary axis. That means is 34 by 5 s square is equal to minus 8.16, and you can take it as s square is equal to minus 40.8 by 34, right? So this is minus 20.4 by 17, that is minus 1.2. So s is equal to plus minus j root over 1.2. So that means plus j 1.1 near to this, and you see this s is equal to plus j 1.1 and minus j 1.1. So there are the 2 points we get. One is j 1.1 like here, and one is j 1. minus j 1.1 here. So definitely the graph which will start from here with an angle of departure minus 72 degree will pass through these 2 points, minus 1.1 j or plus 1.1 j, right? So we will just make it a clear picture of it, and finally draw what is the root locus plot corresponding to this. So I will read the final structure, that is your branch, and you see the values. That means this is minus 1.25, so this is one asymptotes, the four angles you can try with the protectors, and there is a breakaway point at say minus 2.63. this is your breakaway point. Here you will have branch like this, right? So this is k is equal to infinity, this is k is equal to infinity, this is fine. So two branches are already reached, and one is that what you have to do, normally you have to draw minus 72 degree, you have to draw here. That means in clockwise directions there will be an angle minus 72 degree. So similar to that, there will be an angle minus plus 72 degree, and this root locus branch will depart this pole in this axis and going to this path, through this path. Okay, after going certain distance, it actually see that in which direction this has to move, is to move along this asymptote. So this will bend, right, like this, and finally this will pass through the point minus j 1.1, and here this will pass to plus j 1.1, and here k is equal to infinity, right? So this is the problem where we can incorporate all these kind of possibilities. That means there is a possibility of breakaway point, and the breakaway point determination is not easy in this case. We have considered the numerical methods to get the breakaway points. We have considered the complex poles where the root locus branch will depart. That means angle of departure calculations we have shown, and we have shown that there is a case where this branch again touches the imaginary axis, and where the value of k was 8.16. that is very important. This is 8.16. now you see, when the value of k is increasing, these two poles are coming together and they will meet the breakaway point, and finally goes to the S plane via this asymptote and this asymptote, and rest of the two poles, two branches will be originating. And as these are in the this means this in the complex plane, so angle of departure is calculated by using the angle of departure. This branch leaves this pole and finally moves towards the infinity along this asymptote through the point j 1.1, where the value of k is 8.16. now the last part of this problem is that we have to find the value of k. We have to find the value of k. To find the value of k, to find out the value of k, where to find value of k when the damping ratio psi equal to 0.5, right? The question is that you have to find out the value of k when the value of psi is equal to 0.5, and you see this this calculation is not been described earlier. So now what we have to do, we have to consider the damping ratio is given as 0.5. once the damping ratio is 0.5, that means from the concept of time response analysis, we can see that from the time response analysis, this xi is nothing but cos of theta, that is your 0.5. that means theta is equal to cos inverse 0.5, and this theta, this angle, actually we have to measure. And during the discussion of the time response and root locus fundamentals, we have discussed what is the role of this theta. This is actually a theta which is to be made with the you will see with the origin. That means what you have to do in this case, I can show. So cos inverse, you know, this is theta. That means there is certain angle we will get cos inverse xi. So for any damping ratio will be given to you, you will be having to that means you have to find the value of that angle, that is theta. What is this theta? This theta is to be made with this 0, right? This is the procedure. See, I'm making an angle. So cos inverse 0.5, say this is 45 degree. Cos inverse half, sorry, this is 60 degree, right? So cos inverse half 0.5 means 60 degree. So you have to make an angle of 60 degree with respect to horizontal line with this point, with respect to horizontal line. That means I am taking an angle of 60 degrees. Just put the protector here. If you put the protector here, you get at this point, this is protector is placed here. At this point, I am making an angle of 60 degree with this angle. This is the angle theta, right? This is the angle theta, and this angle is measured in clockwise direction with respect to this horizontal axis. See, this is your horizontal axis and this is the angle cos inverse theta. So cos inverse xi, this is nothing but cos inverse xi. So whenever defined damping coefficient is given, you get the theta and you make an angle here, and this line, see, this line will touch this part of the root locus branch at a point, say A, right? So once you get this point, definitely the coordinate of this point can be determined, right? Coordinate of this point can be determined. How the point can be determined? You see, this is your imaginary axis corresponding to this, and this is your real axis corresponding to this. That means the coordinate of point A is something like, say, if this is 0, this is -1, so in between this, say, maybe -0.5. You have to measure this value exactly. I am not getting here from this board, actually from the graph you can measure the real axis component 0.5 maybe, and here you can see this is plus, because in this this is second quadrant, so this is plus j of, I can take it as 0.96. So you have found the coordinate of A. That means what is the value of A? That means at A S is equal to -0.5 plus j 0.9, right? Now you know how to find out the value of k at any value of S, right? So how to find out the value of k at any value of S? That is, you know, I can write here. So GS HS at any value of S is equal to 1. That is the magnitude criteria, and by using this value of S, that means GS of HS, mod of GS HS means mod of this, so mod of GS HS, and you put the value of S is equal to this -0.5 plus j 0.9. So once you put this value, you will get certain value of k from here. These equations already we have derived how to get the value of k, I mean the value of gain at different values of S. So here the value of S is complex, so put this value and get the modulus of it, and finally multiply these values to get the value of k. So from here you will definitely get the value of k. So this is all about the root locus plot and different kinds of root locus plot. I have discussed with all these delicate or intricate issues, theories behind it, and finally I hope for all you can just be able to get the solution of any kind of problem given to you in any kind of examinations, right? So this is all about the root locus plot, and in the next class onwards we will discuss about the frequency response analysis. So out of the frequency response analysis, there are normally two parts. One is Nyquist or polar plot section, one is Bode plot sections. So step by step, one by one, we will discuss them all, right? Thank you.